Hello, everyone. We are live. If my background looks different, that's because I am in Tokyo right now. I'm in an Airbnb. So just a little bit of behind the scenes. Let me just solo screen just to show you what's behind the scenes. It's, we're in like a double bunk bed. My daughter's up there. My wife and sister are sleeping down there. And it's 1 hour ahead in Japan. So land of the rising sun. It means also sun sets earlier. It's 10 p.m. here. Got Kelvin joining us back in the channel again. Hello, Kelvin.
Hello, everybody. So
And
yeah, Darren, I'm checking the YouTube stream. It doesn't seem to be
yes,
on. Is it on?
I see two people. Let's see. Is the YouTube stream on? The broadcast looks live, Kelvin. Let me just
Yeah,
do a quick check. I see
maybe
two
let's
other
check.
people as well. So I think probably it's a short delay. But hello, everyone.
Probably.
Kelvin, welcome back. As we just wait for the rest to join, our topic today is about virtual reality in manufacturing. For some context here, the consumer world, we've already started using virtual reality with tools like Oculus Rift and also like the PlayStation VR 2. I've got a PlayStation 5. I'm quite tempted to get the VR 2, but there aren't that many games available yet. So, any of you are usually using any VR devices, please let us know down in the comments. Now, some also believe that Apple may launch their first VR device in WWDC this June. I'm an Apple investor, and it sounds like the rumors are coming in pretty hot there. Now, beyond the consumer world, actually in the manufacturing world, car companies are also using this to help them with their manufacturing. Recently, a few weeks ago, there was news that BMW just opened their first virtual factory with Nvidia, and they call it the Nvidia Omniverse. So this news is sparking conversation. Like, what exactly is VR doing in manufacturing? What's the benefit? How can we learn more? And think bottom line to what does this mean as investors? Is this useful? Is this like gigapress, or is this just something that is not important to me as an investor? So to this video, we've got Kelvin. Now, Kelvin actually has subject matter expert as a simulation engineer in Nokia and also in Continental, European, German car parts manufacturer. To help us understand, unpack this a little bit. What is VR in car manufacturing? How can companies like Tesla use it to their advantage? So click subscribe, stay updated to more live streams on Tesla. If you're on a live stream, you want to say hi, just say hi in the chat. Look forward to saying hi to you. We'll take your live questions. Kelvin, how are you doing?
Hi, great. Great to have to be here. So thanks for the invitation, and I'm also very glad to share what I have been doing since I graduated from university. So I'm just some background, probably just to share with everyone where I'm coming from. So I worked for Nokia since 2008 as a simulations engineer, so mainly in mechanical simulations. And then I moved to Continental in 2012, and I left the industry in 2015. So I have roughly 7 years of experience in the industry.
Mm,
So so I'm happy to share my expertise or at least my experience. I'm already left the industry, so there may be a gap in in the advancements, but I guess more or less the basics are still the same. So thank you, Darren, again for inviting me. And maybe you can let me just maybe introduce a bit, or maybe start off, get the ball rolling with what is virtual reality and what is simulations in the manufacturing world. So what we learn from, or what we know now, or from video games, right? We have virtual reality or augmented reality, and all these. It's a reflection of reality, right? So when we do it in the games, we do it as a form of entertainment. So it's not too much data driven. So we are just trying to reflect reality. So of course, in games, you don't try to make it 100% reality, because it's going to be a very boring game,
mm,
right? So there's definitely an artistic license to virtual reality. But in engineering world, we try to reflect reality as much as possible. So there's a lot of mathematics behind. There's a lot of efforts to make sure the material inputs, the data that we feed into the simulation engine to be as accurate as possible, so that it can reflect the real physics as accurate as possible. And these are all used to drive decision making. And it is a very important tool, and it's getting more important today, even more than before. And I hope to impart maybe whatever that comes to your mind as this show goes on.
Thanks, Kelvin. So let's visualize this a little bit. So as we bring up
Mm,
this some images on the screen, maybe Kelvin, you walk us through like what you see or what you notice. So
okay,
dive into this topic. Like okay, BMW says we're rolling out this Nvidia Omniverse. So
okay,
when you see something like this, is it something that is new? It's very old. What do you notice?
okay. So I think what Nvidia and BMW is collaborating here is actually more of a marketing push for Nvidia's solutions. Even before the the recent AI trend and computing trend, we have already done. I mean, in the industry, there are already a lot of tools and a lot of expertise being invested in trying to design a factory. So, what the usual, or rather, what the previous generations were, what we were doing before, is that there's a lot of less virtual tools, more data driven, like on Excel sheets, or you have calculation tools, you have computer aided software, computer aided design tools, CAD tools that can help in providing decision making to build out a factory. But of course, this is quite fragmented, as different vendors in the manufacturing space would have different software tools. Some internal in the like BMW or Mercedes. Some are external, so they have different ways of driving that manufacturing design and factory design. So for what we see now is the push from the um, computing hardware provider instead of a software provider. So Nvidia as a hardware provider is starting to move into this space as well. So they are bringing their knowledge or expertise in that hardware and combine it with their AI expertise and
Hmm.
their computing power to provide a more maybe user-friendly tool or a more powerful tool to the industry. As
Hmm.
before, it's, I can say, in a more diplomatic way, is that it's very hard to use. Most of the tools are not very user-friendly, and also due to the fact that the limitation of computing power 10 years ago is really day and night nowadays. If you compare it from what we can do before and what we can do now.
Got it. So
Mm.
when we think of technology like this, before we dive in further, most of the people watching this channel are Tesla investors. So when they hear something like a Tesla Giga Press, the bottom line is 70 different parts into one part, lower cost, lower materials, better structural stability. What's the bottom line benefit of VR in manufacturing?
Okay, if you just want to straight away go to the bottom line, then of course, um, there will definitely be speed advantages where you can design, plan out the factory, plan out your products, which I will go into later,
Yes.
and it will definitely help in the bottom line. I mean, it has been our, as a simulation engineer, it has been our fight from the start that simulations should play a bigger role in any product development programs. So the problem with what we have before is that due to the limitation of the computing power, and
Yeah.
also and because of that, it affects the speed of iterations, because you need
Yeah.
to run simulations which cost time, and also you need the money to invest in the computing hardware. So it was quite difficult to justify before that simulations are important. So because it's not a direct one-to-one translatable invest.
Mm.
So a lot of management or a lot of decision makers, they tend to say, okay, instead of investing so much in simulations, let's do testing instead, or let's change our processes, or let's do something else which has a more direct influence towards the product. But we are very fortunate now to see that more industry, more people are acceptable or more accepting, or they see the advantage of having a virtual simulation or a driven process, that, and they see the advantages of that in bringing their products earlier to the market.
Very clear, Kelvin. When you look at what Nvidia is doing with BMW, so when we look at visualizations like this or user interface like this,
Mm.
what's the leap or what's the big technological progress here that you did not see during your time as a simulation
Mm.
engineer?
Yeah, before that, if you go to the previous slide, right? Before that, a lot of factory planning software, a lot of robotics design, and a lot of manufacturing planning is all done on 2D or on paper, or on a lot of Excel sheets, calculations, and also a lot from experience from the floor, from the factory floor.
Mm.
So we have a lot of stakeholders, and then from the construction of the factory to the product manager to the engineers on site, and also on the people themselves who's going to do the assembly and so on. So you need a lot of interfaces, and of course it can be managed, but as you see, as time goes on, when you have tools that can consolidate all of this information together and put it in a more visual aspect, and also to simplify the use of these kind of tools, it definitely will help the decision makers to make better decisions. So as you
Mm.
can see, it's not only planning the floor space, it's also planning the processes. You're also
Mm.
planning the power usage. You're also planning the lubricant usage. Lubricants, you need pumps to lubricate the machines. There are a lot of things that can be done. So previously, a lot of things are done, through experience or through feedback from the floor, or feedback from the vendors or from the
Yeah.
robots manufacturers. You tend to sometimes iterate is a bit slower, or you tend to, maybe sometimes you can't make decisions that fast, because you need to um, you don't see in a bigger picture, so not that early. So with these tools, if you go to the next slide, right, if you have tools that is easier to use, can drag
Mm.
and drop, you can visualize that space, right, then it definitely will provide that communication easier to all the stakeholders, and also to have a faster iteration process. You can drop new machines. You can, definitely with AI nowadays, right? You can let it optimize it, and then you supervise it, instead of making everything manual, where instead of doing trial and error, or from the experience of an engineer, you set a certain constraints and certain parameters. The system will optimize it. So I'm sure that is what Nvidia will be going towards too. So it will definitely help a lot of processes, especially in manufacturing. So in the future, I'm quite sure that you will see um, more companies going to automation, especially with these tools.
To me, as an outsider, it feels like the leap from MS-DOS to Windows, where now it's a lot more intuitive. The graphical interface is more accessible. it's kind of like me as a noob using Mid-Journey AI to create images. And so what I'm sensing or hearing from you is that the technological progress now allows simulation to be a much more powerful use in car manufacturing.
Yes, what we have, what I have personally experienced is that sometimes we present results from our simulations, right? We present it in a way that we try to make it understandable to the decision makers, because as you know, not everyone has an engineering background and not everyone can understand charts and numbers. So I'm sure with this kind of tools, it's much easier to present the optimization improvements. It's much easier to communicate the advantage of using a certain process to the decision makers. Because in previous times I have done, when you just show numbers, they have no sense of, how much is it, how much will this affect the bottom line and so on. So if you can present it in a more friendlier way, or you can present it in a way where everyone can understand, right, it definitely will help. And I'm sure with the computing power nowadays, the iterations will be faster. I used to spend like to create a model, to prepare a mobile phone model. I used to spend like 2 weeks just to prepare the model, and then to run the simulations. For each simulation run, it will take like 2 hours, and then after that you need to have a few more hours to prepare to get the results, to process the results, to show it, to tabulate it, and then to provide the information. So all in all, that one iteration may take 3 weeks or so. So it will be when we have better computing, computing power and more and better hardware, better software, it will definitely help these kind of processes.
Very interesting. Now, for anyone watching this live stream, like I'm not an engineer. My purpose here is to really understand this as a lay person. So I believe for Tesla investors, the more we understand the fundamentals of a company and what most other retail institutional investors don't see, the better we are at finding alpha or the difference or superior returns. Knowledge is a tree, and we should begin in the roots, which is I think Kelvin wants to walk us through like what is the actual product development cycle and what role does simulations fit in. So some context here as I was doing some research on this topic together with Kelvin last week. Uh, this whole field actually started back in 1957 with the first CAD, computer aided design. And again, simulations is building on like simple computer aided design used by engineers, architects, and now into the very complex world of manufacturing. So I'll bring up a visualization, some visualization that Kelvin has provided. Maybe we start off first with product development, if that works for you.
Sure, sure. So any company with a more or less complex product, there's a typical product development process. So for every iteration or every phase in a project or a program, right, you will have decision making gates, you have quality gates, and then you have things you need to check off, you need to do, right?
Mhm.
So this is a more or less a linear process, which has I'm quite sure it has not been changed much, especially for a physical product. So let's start from the left, right? So when we start a product, there will definitely be some feasibility studies that will be performed. So we have to make sure that this product can be done, can be manufactured, can be sold, and there's a business case to it, right? So if it's a physical product, especially like an engineering product, right, we will start off with some simulations, right, to show that at least this can be done. So the design phase will be there. We'll work together with a lot of simulation engineers and product marketing, and so on. So they will have like a sort of a first build, prototype build. So all this will then, continue on during the project phase, the product phase, and then it will drive towards building a prototype. So for any physical product, there must be a development prototype or something that you have to build to show that it is feasible to be done. A physical product that can be touched, can be shown to stakeholders and to test. So all this is being also supported by simulations. So simulations usually is being done all throughout that development process. So I've actually also gone through the whole process. And it's also a very iterative kind of work. So it works. We work very closely to the prototyping team where they build the physical prototype. So we give our feedback there, and they do it. They do the changes as time goes on, and also testing as well. So we verify also our changes with testing. Then at the end, the production comes, but not to forget that after a product is launched or produced, right, manufactured, some people thought that, okay, that's done, everything is done, we just need to sell. So it's not the case in a lot of products, especially in cars, in mobile phones. There's still a maintenance phase after that. So as cars, there are recalls, there are errors in production, there are maybe for mobile phones, they're even running changes. You're changing a more cheaper speaker or whatever. So all these simulations play a part as well in the decision making process. So instead of making a change and causing a problem later on, we simulate it to see if it's feasible or not. So this is where the simulation comes in. It's not really true nowadays that if you follow this chart, it's not really true that you do in a linear way where you do the model, you simulate, at the bottom part, you do testing, and then there's a final design. It's not really true anymore, especially for a very complex product. So it's always a iterative process. So this kind of iterative process can only be done if you do simulations, because you do not, the cost is relatively cheaper if you do it early, and also you do not need to engage too many stakeholders. Like if you want to build a physical prototype, you can see that you need to engage suppliers, you need to engage so many other stakeholders. You need to engage the costing part as well, the buying or the purchasing. But for simulations, you can do a change, you can test a material without actually needing to engage all these people yet.
I'm
So
curious,
this is the
Kelvin,
typical, yeah.
when a company like Tesla, they're making EVs, which has a lot less moving parts, and they're using technology like GitHub Press from 70 parts versus one big piece, one gig cast, one front, one back. Does it just make the job of simulations a lot more simpler? Does it work that way? Or what am I missing?
Not really though, because even if you, let's say you are from 70 parts to one part, right?
Yeah.
You first need to either you are a superb engineer where you can actually do all the calculations in your mind, or you try it in simulations. That means you take that part, you design a CAD model, you replace it in your existing build, and then you do simulations on it. You do crash tests. The crash test is the digital crash test, the simulation crash test, not the real one, because the real one is going to cost a lot of money. So we do the simulations first. That means we see if it's feasible with the materials we have. And then to do that casting, there's also a mold flow simulation. That means the casting simulation. You're not going to buy a part, build the mold, and then do testing on the part. That's going to cost millions or even tens of millions. There's no one is going to do that. But to hire an engineer to design that in the CAD model first, and then run simulations based on the physical properties that we know that the aluminium has, that the design will have, it saves a lot of money and a lot of time. So once you have a sort of feasible model that you see, okay, it can be done, then only you start the building of that tool. You start the ordering of that machine, and you start to implement that process into the production. So that is typically what the program will do, what the product program will do. So there's no such thing as saying suddenly I dream of, okay, let's do casting. Okay, tomorrow we go and buy the machine, we go and buy the tools, we go and try it out. There's no such thing like that. You definitely have to do some calculations, and then of course there's a limit to our human prowess, right? I mean, human intelligence, that we cannot do everything in our mind. So we need the aid of computers, and that's where simulations come in. So we know the basic properties of a certain material, we know the basic design principles that we need to have, and then we bring it into the digital world, the virtual world, and then we do simulations. That means we put constraints, we put loads, we put whatever we think the product may undergo, whatever we think that it must pass, and then the results will show us the direction. Is it correct that we choose this certain process?
Now, these simulations, they're not just saving material because like you don't want to crash a lot of cars, but I can imagine it's also saving a lot of time because let's say you want to test 100
Definitely.
scenarios at the same time, not in a
Yes.
linear way.
Yes. Especially with computing power nowadays, right? It's very
Yeah,
trivial. I would say it's just a matter of cost. It's a matter of, do you want to pay for that computing power? And then with cloud computing nowadays, you can pay on demand. You can
yeah,
pay when you need it. So previously, when I was in Nokia, we had to maintain a computing cluster, and then we have to have a team, to maintain the software, maintain the hardware, and then provide support. So that's all lots of money. Software itself is also not cheap. But nowadays, with even computing on demand, right? So you just pay what you need, lah. So it's very calculable. You can very easily justify that cost.
I think that appeals to different companies in different ways. For a lot of automakers which are margin constrained, saving money is really important. I think for Tesla, Elon Musk was saying that you can waste money, you can waste material, but you cannot waste our time. Do not waste time. And simulation is
Yeah.
very powerful there. I think you also
Yes.
highlighted, Calvin, that the usage of simulations is very broad. Can you walk us through some of these potential use cases here?
Yes. So maybe for a layman, right, we do not know what can we really simulate in the computer. So this is just an example of a software vendor, MSC. So on itself, they very likely provide a solution. That means they say, okay, we are a simulation software company, we can
Mm,
do all this. So in the engineering, in the real life, we break it down by disciplines. So every discipline has a software. That means because different physics require different solutions, all right?
mm,
So for example, let's start with the top one, structural and thermal. This is one of the oldest disciplines, structural. So you can do it with a pen and paper, but you can only do it in very simple structures like a beam, a truss, or like a simple cylinder or whatever. Right? We have simple structures. The architects they can do calculations on a piece of paper.
mm.
But when you go to complex designs, you need the computers. So my field of expertise is in this one. I'm trained in a finite element method. It's a method for simulations. So they use different how do I say that? Uh, it has a computer science part to it, how you solve mathematical equations, and there's an engineering part to it, how you solve real world problems, right? So I'm not in that computer science part. I use that software. So I'm not very well versed in that. I just know very uh, basic principles, but I use that software to drive my engineering decisions.
Mm,
So, for example, you want to ensure a certain feature in your design can withstand a certain load or a certain pressure or certain temperature and so on.
mm.
So we have to apply that. So that's mainly what I have done before. So that's one of the discipline. So structural and thermal, it interplays quite well together. Then of course, the next one is that in our world, not many things are linear. So they go a step further, non-linear structural, which you can see on this screen,
What does
top
this mean for
right.
for a layman like me?
Yeah, not non-linear means that, okay, for example, let's say a very simple case now, let's say, right? If you take a paper clip,
Mm,
right, and then you apply a stress to it, that means let's say this is a paper clip, let's say this is a paper clip, right? So let's say this is aluminium, let's say, right?
mm,
So there is a certain equation to it.
Mm.
A piece of metal, let's say aluminium, right? They have a certain part where it's linear. That means how much stress you pull, it will strain. That means it will elongate at a uh, certain what do you call it, distance. Let's say distance. We call this a strain. Strain,
Mm.
like a spring. A spring
Mm.
is highly linear actually, because when you pull the spring, you let go, it goes back to the original part. But
Mm.
in real life, if you pull the spring too far, it won't go back to its original part, right?
Mm.
Original dimension,
Correct.
right? You have you broken the spring before? I'm sure
Yeah.
every kid in us, right, have pull out the mechanical pencil and pull the spring. So you have broken the spring before, right? So that's where the non-linear part comes in. So this is one
Got it.
part of non-linearity, one part of it. There's more non-linearity in our world, like contacts. Even contacts between two parts is highly
Uh,
non-linear. So it's very complex mathematics. I'm not gonna go into it too deep. No one will understand actually. I also took a few months to understand, but you know, in this world there are a lot of non-linearity. So that's the next iteration, and that's what a lot of problems are being done. Like plasticity, yes. No, like crash test. When you
yeah.
crash a car, the car deforms, right? That's plastic
Yeah.
deformation. The plastic is not the plastic that we use. No, it means that the energy is being absorbed by that metal, right? So that the energy does not transfer to the passenger inside the car. So that's
Mm.
highly non-linear. It's very non-linear. So these are all you need simulations or you need real world testing to actually drive your decision making. So if you see this car, right, you see how many parts are there model. This is a very, very detailed model. In my time, we cannot do this. Not in this form.
Mm.
So probably in some cars, in some manufacturers they do, but I was in the mobile phone industry, so we don't have that kind of money to do these kind of things. So, and also you see the airbags is opening at the same time. So this is also, there's not only structural simulations. If you go back, air is very fluid. So it's actually a fluid simulation as well, how the airbags behave. So if you go back, Darren, if you can go back to the disciplines,
Mm.
right? So when you go to which one? The bottom left, cradle, right? So this
Mm.
is just a brand name lah. So it's fluid and thermal. So the air in the airbag is considered a fluid. So you need to have a different kind of mathematical equation to solve that, and to be able to put the airbag simulation plus the crash test simulation. That's something that is non-trivial at all. It's a very complex process. Previously, we did something where we uncouple it because it's two different simulations. So we have to simulate one part, simulate the other part, and then we use the outputs from the one part to bring it to the other simulation. So it's very uncoupled. There's no feedback. But nowadays, with computing power, with new computer science, right, you can couple it
Mm.
together like what we have seen just now with the crash test. You can have the airbags deployed at the same time during the crash test, and you can get uh, the very, very accurate results.
Very clear. It
Mhm.
sounds like there's some very obvious benefits of simulation, and I think you put it very clearly here in this chart. One
Mm.
question I want to ask you about on this here, Kelvin, and again, I also want to take this opportunity to say hi to Simon, hi to our friends in the live stream. If it gets too
Hello.
technical, you want to ask the simple questions, ask in chat.
Yes.
Let us know.
Yes.
The whole point here is to again separate the noise from the signal for investors, especially long-term investors. That's a primary focus of this deep dive. Kelvin, when we look at something like this, what is something that is not obvious but is a very powerful benefit of simulation?
What is not obvious is that a lot of companies tend to don't want to invest in simulations because firstly, simulations is firstly not cheap because you need to pay for the computing power. You need to pay for the software. A software simulation software can run from a license can run from like upwards of $250,000 a year. It's not cheap at all. And then to hire an engineer to actually know how to use it, an engineer costs like 150,000, 200,000, right? If everything a year. And then you need to have the support because you need to have your stakeholders, the whole company to be behind that, to actually use that and believe that simulation can drive that product or can drive the decision making process. It's also a cultural change. And that was what I was fighting when I was working also. We have a lot of, let's say, objections, maybe, right? Or maybe not so high trust in simulations because probably they don't understand or they probably think that uh, let's just build it first. Let's just see what I have, what I know before to work. I know it will work if we do it this way. So that was the
Mm.
old way of thinking. I mean, I'm sure a
Yeah.
lot of companies are still working on that way, but as human labor gets more expensive, as computing power gets cheaper, as software gets cheaper, as materials gets more expensive, then we will tend to see, okay, simulations can help us in making that decision earlier. So that chart previously is showing that if you make a change too late in a product development, it's going to cost way more than
Mm-hmm.
if you change early. So a lot of people don't see that because they don't have a comparison during that production process, because when they don't change at the first time, they have no way to compare how expensive a change later will be. Because if you
That's right.
don't do simulations, you change later, you have no anchor point, right? You cannot compare you because you have not spent money before, so you don't know how much it costs. But if you
Mm.
look at the big picture with a lot of studies done already, it's very obvious that if you change earlier in the process and you have a decision making based on simulations, you tend to spend less later on. So that's what the chart was about.
And as you call out, culture is a non-obvious thing here. A lot of people think it's
Yes,
just
culture is not
buying.
obvious.
It's not just buying the technology; it's how you use it and your mindset towards it.
Yes, yes, and
Ivan is
and
saying,
it's not, and the simulation is also a tool, like any other tool. If you
yeah,
put garbage in, it will be garbage out. So
yeah,
you need to have that certain mindset and a certain expertise in the company to understand that whatever you run or whatever decision making process you have, there's a certain trust in that simulations engineer or the person that's running the simulations, to know that, okay, this will help in the in the in the whole product development process.
and that's precisely why culture is so important, even in the such a scientific world of engineering. Ivan is sharing in the chat
Mhm.
that the capabilities of these tools are expanding so much, like the Nvidia Omniverse allows you to basically run and simulate an entire production line, not just one process. And the
Yes,
capabilities will only get better. Like whatever we see in
yes.
something like Nvidia Omniverse today, it's its worst possible state. It only gets better every
Exactly. Yes. Like Ivan Lee states, you can let AI optimize, which is very true, because when you have a data driven process where you do simulations, and then if you trust the data that you put in, and you trust from what you get, right, the best
Mm,
optimization is always getting the computer to do it, right, if you have a certain intelligence towards it. Previously, I've done optimization in engineering as well. There are different methods of optimization, so you can read that uh, in literature. But if you put in intelligence, it's not just a mathematical process anymore, right?
mm.
Because if you have intelligence, you can actually uh, improve it in such a way that it's not just a simple mathematical optimization. It's actually based on different inputs. You actually also based on experience, and you also based on um, a deeper understanding of the subject at hand.
With all of this, even with all progress, nothing is perfect, and it's the same situation as simulations. So you put together like a simple one pager on how it isn't always perfect, but it's still the least bad alternative to not using simulations. Tell us
Yeah,
more. Do you have
yeah,
any story to share here?
yes. So as we know, right, simulations is just a numerical model. That means it's based on mathematics. So it's a simplistic representation of a real physics. So real physics are actually very complex and actually also highly chaotic. That means we may not have, let's say we do the crash test, right? We may not have, during our simulations, we may not have the humidity in the test or in
Mm,
the simulations. We don't have, maybe we don't have the data of temperature at that time, right? Because we, um, from our experience or from the data, our the material behavior is not influenced by temperature or humidity, let's say, or maybe
mm,
the time of the day, or maybe where the sun is, the magnetic pole, or whatever. We don't
mm.
have that data, so we cannot put it in our numerical model, right? But in real life, no matter how small, right, this might play a certain influence in the result. So it's definitely
Right.
not 100% real, but right, it's better than going in blind, right? It's better than, I'm just saying that, right? Like, let's say you are going to make a decision, you want to reduce a screw or what, right? You can, instead of just saying, okay, let's just remove it because you want to save cost. But then later the car will creak in a certain way, right? So instead of going in blind, why don't we remove the screw in the simulation first and then see what happens? So if you can, at least you eliminate those obvious and those problems that can be simulated. So
Agree.
that is what I mean, because as you know, nothing is perfect in the virtual world. We cannot simulate, right, 100%, but at least you have a direction. So you reduce your mistakes, and this will help you drive your decision making faster and save costs and time and so on.
So it's directionally helpful. It's kind of like Tesla autopilot. It's not perfect, but it is safer on average than a human driver. So
Yeah,
use it, even though it's not perfect. These
yeah,
tools get better over time.
it will
Tell us a little
definitely
bit
get
more
better.
about what the future has in in play for simulations.
Mhm. So what I see, like nowadays, I mean, this is not comprehensive, of course, but what I think that the future will be in store is that it will trickle down more to the physical world, so you can blur the lines between virtual and physical world. So like
Mm,
what I've shown on the left hand side, so you can actually train the assembly workers using AR, using VR. So the VR or whatever the experience is has the physical properties of the real materials, the real assembly line, and so on. So they can train faster, a cheaper way as well, because you do not need to be physically there at the factory. And of course, sometimes even the factory is not done yet, right? So you can already start to do training and so on. So this is maybe one direction. It's actually not science fiction, it's actually being done already. To be honest, I was part of a study with Daimler when I was a student already. Even in when I was a student, it was like, how old am I? Yeah, about 20 years ago already. There's already augmented reality. So I was just
mm.
part of a study. I was not involved in the research, but I volunteered to be the test subject. So actually, it has already, it's old technology, but it's starting to be cheap enough and starting to be good enough to be used. So that's what I see. I think Volkswagen is already using this to train their assembly workers for their electric vehicle production.
Mm.
So it's not very, say, state of the art, but I can definitely see it getting cheaper and more manufacturers, even not only in cars but in other products, to use this to train. And another one is what just now Ivan said, I think,
Yeah.
regarding AI. So especially when everything is virtual, a lot of things is virtual, right? You do not only drive your product development decisions, but you actually can drive your business decisions as well. So, for
Mm.
example, you can simulate uh, what if instead of borrowing from the bank, you issue new shares, you sell shares to get capital instead of borrowing from the bank. And even a CFO can use these kind of tools to simulate what will happen. So you can actually assist using AI to drive your these kind of decisions. So you can even, in let's say a CEO, before Elon Musk tweets funding secured, he can actually put that tweet in a virtual world and see what is the repercussions. All this. I mean, that's what I mean. Like instead of just the product, you can actually drive business decisions as well. So I think that is
That's
the
good.
future.
I agree. If you have technology to stimulate entire production line now, what's the leap? Is like simulating like a political scenario and environment.
Yes,
There's so much
exactly.
possibilities for better and worse. Now,
You can
this
simulate, like, the
yeah,
uh market reaction. You can simulate like the hive mind, like the humanity, how would they react and so on. Yeah.
this is a powerful tool. You said garbage in, garbage out. What Tesla prides itself on is acting fast, innovating, and again, first principles thinking. How can Tesla use all the advances in simulations to be an even better company and ultimately a better investment for us as shareholders?
Yeah, so I think the last slide was based on your question, like how would simulations, be an advantage to Tesla. So Tesla has been well known to base their whole company on first principles, right? They tend to not be bogged down by legacy thinking or by what people have done before. So simulations actually accelerates that, actually helps that kind of culture. So um, instead of saying that we have done this before, so we should do it again, right? So you
Mm,
use simulations to drive that decision making. So you simulate and then you decide, instead of test and then see, or wait and see and so on, like what some companies do.
mm,
And it also helps in the Silicon Valley kind of startup thinking, right? You fail fast, you fail often, but of course, if you use simulations, you do it at a lower cost, because when you fail in a computer, right, you can just do it again, change it again, change the
that's right.
material or whatever, instead of needing to buy and uh, pro- do the whole process all over again.
And actually, if you look at the company culture, like companies that Elon Musk run, I mean, we've seen though the 1 minute video clip with all the Falcon 9 rockets just crash, exploded. Even if they fail in physical world, they still they don't give up. And I think simulations is a powerful way to just test, push, push, push until you really create something new. Like how Toyota is so impressed by Tesla's current way of making the Model Y, but Tesla's like, nah, we're going to do it even 50% cheaper. We talked about that in an earlier video together. We know that Tesla is
Yeah.
using simulations on other things, even like training neural nets, autopilots. When it comes to simulation in manufacturing, Tesla is known as a company that likes to vertically integrate in-house thing. Is there any competitive advantage or benefit you can think of Tesla trying to do it in-house? Or should they just use like those third-party simulations providers? What's your view?
I think there is no advantage if they can do it themselves, because the mathematics behind it is actually all not proprietary, like how
Mm,
to solve certain problems. What they can do in house is that the materials they use, the material properties,
mm,
that's the mode actually, the mode
mm,
to use that simulation solver. So we actually have we actually when you are simulating, right, you actually buy the software. The software is actually called a solver. So you solve
mm,
that problem. But the mode that the company has is actually on the material properties. That means the inputs that you put into that solver. So, like what we have in Nokia before, what is proprietary to us is actually the material data. The same with BMW, the same with Daimler. You cannot get the data one. You have to. There's no such thing. You cannot. They will never sell it on, because the data is
agree.
they got the data from experience, from years of testing, from verifying their simulations to the real life. So you will never get the data. So that is the mode that I think Tesla will have, which is the same with any other company. If you're willing to invest money to get that data, you will have it. So that's the only mode I think they can have. If you're talking about the software or the tool, I don't think I don't see an advantage for Tesla to develop a new solver or something, unless there
Mm.
is a problem that has not been solved.
Mm.
Then they probably can use their computer science prowess to solve that equation. So there's a famous equation, the Navier-Stokes equation, which is part of the Millennium Prize. Have you heard of it before? Where if
No, sorry.
you can prove that it's solvable or not solvable, right? You get $1 million. So the Navier-Stokes equation
Wow.
in the CFD simulation in fluid. It's said to you, maybe you can put on the board or one thing. It's to
Let me do
solve
that.
fluid behavior. Yeah. So you
Huh.
see, it's describe the motion of viscous fluid substances. So
Mm.
this is not solved yet, right? So you if you can solve that and then you can put it in a numerical method, then you may have the advantage. You can actually sell
Wow.
that. So
So,
now there is solver for fluids, but it uses certain assumptions.
mm.
Mm.
So,
But
any of you
this
want to earn
equation
a
is
million
not.
dollars? Let's solve the
Yeah,
Navier-Stokes equation right now.
yeah. But this equation is, I think, is the thing to get the $1 million is that you can actually also prove that it's not solvable. If you can prove that it's not solvable, you can also get the money. Something like that. Yeah.
Well, there you go.
I'm not a mathematician. I'm not in computer science, so I don't know if what I said was true or not. But what I know is that this describes a physical behavior of fluid.
Yeah,
So if you can somehow numerically put it into a solver, then probably there's an advantage.
very clear. For everyone on live stream, if any questions or comments or statements, feel free to share. I'll bring it up from the chat. Again, Kelvin, I always learn a lot from you when we have our conversations. Today is a far more technical topic than we usually
Mm,
go into, but I think that all these are small like Lego pieces that just expands our knowledge. I'm curious, Kelvin, like is there anything specifically that you're hoping to build in your own knowledge as an investor this year?
mm, Probably understand more how to read financial reports.
Mm,
Maybe to understand the mechanics, like economics, macroeconomics, maybe understand a bit more about interest rates and so on. What I have is very surface. I learn from
mm,
the community as well,
mm.
but of course, to there's all these new things to learn. So I hope to improve myself on that aspect.
Thank you for sharing. I think knowledge is a double-edged sword. Sometimes the more we know, it doesn't always help. Sometimes it can paralyze. What I mean by that, like example, like Kelvin mentioned, like macroeconomics, right? So I think Warren Buffett was saying the way he invests, he just invests in companies with strong fundamentals because he's been doing like this for like 5, 6 decades. And he said he couldn't predicted the Vietnam War, couldn't predicted 9/11, he couldn't predicted the Lehman crisis, couldn't predicted the Iran war, the Iraq wars, and all the things that have happened. And yet, generally, like companies with a strong foundation typically trend upwards.
Mm,
So as I learn about topics like this with Calvin or everything else as well we in our life, I do wonder like how do we filter, how do we curate, how do we ensure that it's useful signal. So if any
mm,
of you have any tips for Calvin and I, like how do you process knowledge? How do you use it? How do you make sure that knowledge serves you and not you serve knowledge? I think
yeah.
that's a powerful way to live a life.
Yeah, but probably maybe what I said just now was more on a personal level, not to say that
Mm,
it will definitely or affect or influence my decision on investing or investing
mm,
decisions, but I have a personal interest in learning about economics. So I started
Mm,
to have an interest in that by reading Freakonomics, by following
mm,
the people behind Freakonomics. So it makes me um, it I like the way that how human behavior, can affect decision making, can affect the the financial world and so on. So I think that's what I want to build upon, and then I want to see how that behavior can affect, financial decisions and so on. So maybe not so much, maybe like whether to invest in this company or not, because most likely I will just
mm.
invest in Tesla. So not really influencing anymore, but to learn about how the world revolves, how the world works, and so on.
Thank you so much, Kelvin, for sharing this. Thank you for everyone for joining us in this live stream. You all can follow Kelvin on his Twitter handle, Kelvin LYM. He's been on Twitter since April 2009. Kelvin, when are you getting your blue tick?
I don't know. I don't think it's worth the money. I'll get the blue tick when Tesla is $4,000. Let's see if it happens
Okay,
per
Tesla
share.
4000 blue
Mm.
tick. So this is living on with internet records. $4,000,
Yeah.
Kelvin will get a blue tick. So yeah, Kelvin has a lot of good perspectives. I mean, not necessarily on EVs or Tesla, but also what's going on in Malaysia in general. Kelvin's based in Malaysia, and I'll going to be in Malaysia on 3rd to 6th May. We'll organize a light show. We'll catch up with Kelvin then as well.
Yes.
Kelvin's running a big project right now. Are you using any simulations for your home project?
No. I'm not an architect. I'm not in architecture, but I do
Mm,
use my engineering expertise in decision making though. So
okay.
like the wiring in the house, because I'm
Yeah.
going to install an EV charger. So
Nice.
I told the designer and the wireman to make sure that the wires are prepared for the EV charger, because it's going to take like 60 amps. So you
Yeah.
need different wires, right? So I do not need to hack the wall again when I install the charger. So make sure everything is done. And I'm also preparing the roof for solar panels.
Nice. This is the way.
Yeah.
So, for those of you who enjoy the live streams, if you have any feedback on how we can do better, what you like, please let us know down here, because Kelvin's a great guest, so much to learn. Hope to invite him back in for future topics, whether it's on stock or something technical like this. My next live stream guest at the end of April is going to be from another continent altogether. You're going to hear from my friend Tom. Tom is the president of Tesla Owners West Sweden. So we're going to talk to him about how Tesla is dominating in Europe. We've been seeing a lot of articles recently how Tesla is the number one brand in many European countries. What's going on? I've had the pleasure of meeting Tom 2 times. First time in Berlin in October 2021 when we had the first Giga Berlin opening party and factory tour. And second time in Austin. He also came when they did the TeslaCon Austin as well as the Giga Texas factory tour. He, fun fact, Giga Berlin is now reopening for tours for Tesla owners clubs in Europe. So if you're a club president, you can bring your club members for a factory tour. It's really cool. So Tom is bringing Tesla owners West Sweden for a factory tour, I think on 16 or 17 April to Berlin. So I want to speak with Tom to also hear what did he notice the first and second time in Giga Berlin? Because first time they were not really manufacturing cars. Now they ramped up to 5,000 per week. Giga Berlin's done a great job. So he's going to be my guest. It's going to be at 11 p.m. Thursday, Singapore time, 27 April. The live stream has already been created. Bookmark it, click the notification bell. And thank you, everyone. Whether you're watching this live or later on in the recording, we appreciate it. Click the subscribe
Darren,
button to stay updated to more videos on Tesla. Yes, Calvin.
Darren, ask him if he can see if there are any signs of 4680 line in Berlin.
4680 line. I
Mm.
will. I
Yeah,
will.
ask him to try to take a pic or something like that.
I'll actually give him that prompt right now.
Yeah.
So I'm just going
Mm.
to end the broadcast now. I'm going to have a short chat with Kelvin. But thank you, everyone. I'll see you all very soon.
Bye
ending the
bye.
podcast.